Hi guys, my name is Arya and welcome to this Golang tutorial. We will be thoroughly covering the basics of Golang throughout this tutorial, and I suppose that itself says that we have a lot to learn and look forward to, so let's get started. Now before you learn any language, you should always know why you're learning the language. Every language serves a special purpose, and the very same goes for Golang. So why exactly should someone learn Golang? Well, Golang was built by Google to solve problems they face at Google. Now, at Google, lots of big programs are built for big server software that run on massive clusters. Now, before Go, Google was using languages like C++ and Java to solve problems, but these languages didn't really have the fluidity and ease of construction that was needed for problems of such scale. Keeping these things in mind, a few years ago, Ken Thompson and Robert Kreischer thought about building a new language that would be good for these kinds of problems, and hence Golang was born. Basically, if you're trying to solve a problem of enormous scale or just need an efficient and scalable code, Go should be your go-to language. Now, Go isn't the first to address the need for a scalable and highly efficient program for large-scale programming. So what exactly makes it stand out? Well, the existing languages have been good enough until recent years, but there's been big changes in the computing environment in the last decade, which has included a lot of networking, a lot of cluster computing, or the cloud as you common folks might know it by. Now, the languages that were being used to implement services until now are at least 10 to 20 years old, so there are a lot of properties of modern computing environment that these languages don't address directly. Therefore, having a modern language that works really well in modern computing environment is actually important. But you also want it to be efficient because you're going to be running these on hundreds or maybe even thousands of machines. You also don't want to waste resources by having an inefficient interpreter or some of the problems that generally come up with virtual machine implementations. Golang ticks all these boxes and hence has garnered the much deserved fame in the developers community. Okay, so that was all about Go. It's time we move forward and dive into programming. Now, throughout this tutorial, I'll be explaining various concepts that are general to most programming languages and some concepts which are specific to Go. I'll be showing a small piece of code on the presentation and I'll explain the code and the purpose it serves, and then we will also build a simple program on a text editor using those concepts and then go run them on the terminal. Now, before we start programming, we must also install Go, which is a pretty simple task. Just head over to golang.org, click the download Go button, and install the binaries for your respective operating system. Okay, so now that we are done with the installation bit, let's head over to our first program, which is a very generic Hello World program written in Go. I'll go over the lines of code line by line. So firstly, we have the package main, which means that every Golang program belongs to a package. This actually helps in code readability and code reusability. So after we've defined the package, next we're going to import some general libraries that are going to be used throughout the program. Over here, I've imported the format package, which is used for formatting text on the screen. And as you guys can see, I've also created a main function. And inside the main function, I've used the println method from the format package to print hello world. Okay, so let's see how this program would actually run when actually written on a text editor. So let's head over to our text editor. For me, I'll be using Sublime Text. You all could use anything that you feel comfortable with. So let's start typing. So package main, and then we want to import the format package. Then we have to create the main function, because the main function is what runs when the program is actually executed. It's the first function that runs. And then we have to print hello world. This is my first Go program. Let's save it and let's run it. So to run Go programs, you'll need to open up your terminal from the place you've actually saved your Go program. So now that you've done that, go ahead and type Go run and the name of your program, which is first.go. Okay, so as you guys can see, we've successfully compiled our program and the output is already on the screen. It says, hello world, this is my first Go program, and that's exactly what we had expected. Okay, so that was a very simple program and we have a lot to learn, so let's move on. Okay, so now let's head over to variables and constants. So what exactly is a variable? Well, a variable is nothing but a name given to a storage area that programs can manipulate. Each variable in Go has a specific type, which determines the size and layout of the variable's memory, the range of values that can be stored within the memory, and the set of operations that can be applied to the variable. On the other hand, constants refer to fixed values that the program may not alter during its execution. These fixed values are also called literals. Constants can be of any of the basic data types like integers, floating constants, a character constant, or even a string literal. And there are also enumeration constants as well, and constants are generally treated like regular variables except that their values cannot be modified after their definition. So that was it about variables and constants. Now let's move ahead with data types. I'll show you guys how to actually define and use variables and constants later on while we are programming, so just hold on. So Golang has 4 different types of data types. As you guys can see, they're numeric, derived, Boolean, and string. So numeric data types are any data types that hold numeric value. For example, we have 2 types of numeric data types, that is int and float. Now ints are also of 2 types, that is ints and unsigned ints or uints, and they have a space of 8, 16, 32, and 64. Then there's also floating point values which have decimal precision, and these can be of float 32 type or float 64 type. Then comes derived data types. So derived data types include things like pointers, which is the memory location of any variable, arrays, which is a data structure that contains similar types of data types. Then we have structures, which is another data type in itself for actually creating custom data types. We'll see how we can use them later on. Then we have maps, which are like dictionaries in Python or hash maps in Java. And then we also have interfaces for abstracting our methods. Then we have Boolean data types, which are basically either true or false and are used for decision making and binary decisions. Then we also have string literals, which is just a series of characters, like your name would be a string literal in Go. Okay, so let's also cover operators before we move on to a little more programming, because we've already covered the data types. So Golang has 3 major types of operators that are prevalent in every programming language. That is arithmetic operators, relational operators, and logical operators. So arithmetic operators allow us to perform arithmetic in Go, and we have these 5 operators, which is basically addition, subtraction, multiplication, division, and modulus. Modulus, if you guys don't know, gives us a remainder after division. Then we have relational operators, which is basically used for comparing two values. Now we have the greater than operator, the lesser than, the greater than or equal to, then we have equivalence and not equals to. We also have logical operators, which include and, or, and negation, and these are normally used to implement Boolean logic in our codes. We'll see how these are actually used as we go on with programming. Okay, so let's head over to our text editor and try some of these stuff. So first of all, what we learned is that we have variables. So how exactly is a variable defined in Go? So first of all, we go var a and then the data type, that is int, and we say the value. So var a int equals 5. Now this will actually declare integer variable of value 5. We can also have floating type variables like var b equals float 32 equals 4.32. We also discussed that we have constants, which is const, suppose something like pi, and this could be a float 64, and it's going to be something like 3.141. Now, if you want to declare two variables together, there are a few methods that you could use. First of all, you could say var and open close brackets, and in this bracket, you could say c equals 8 and d equals 7. So there's also the shorthand notation that is very popularly used in Go for actually declaring multiple variables. So that is x comma y could be declared as colon equals to 14 comma 15. So this would declare two variables of integer type, like Go is smart enough to understand that x is an integer and y is an integer too, and it'll declare x equals 14 and y equals 15. So let's actually go and test all these out. So let's print everything. So fmt.println. So a should be 5. Copy this out. So we want to print b then. Then we want to print pi. Then we'll also print x and y. Let's save it and let's run it. Okay. Okay, as you guys can see, we have successfully printed out all the values that we have declared. Now, we also learned that we have operators. So in Go, you have arithmetic operators, Boolean operators, and relational operators. So let's go and test out the arithmetic operators. So let's declare two values, x comma y equals that's 5 comma 6, and let's do some basic arithmetic operations with these guys. So we can also do the arithmetic operations in the print line statement. This is very well supported by Go. So x plus y, let's do it a bit better, equals comma x plus y. So we have subtraction, multiplication, division, and modulus. X minus y, x multiplied by y, x divided by y, and x modulo y. So let's see if this produces results, which it should. Okay, so we have to go run and first program. So as you guys can see, we have the perfect results. 6 by 5 is 0 because it just doesn't go, it's too big, and it's not floating point numbers, so it will not give us precision. Then x 5 multiplied by 6 is 30, 5 minus 6 is minus 1, 5 plus 6 is 11, and we have performed arithmetic. Similarly, we also have booleans. So something like is bool is true. So we could also do this, or we could even declare it like this. So you could go var is boolean and true. So that's the longer way. I'm just going to be using the shorthand. Now for booleans, let's also create another boolean because I want to test something. So let's call hate. Hate is false. Now let's try and print some boolean stuff out. So fmt.println. We can also perform boolean operations here. So is bool and hate. Okay, so this should print false and this should print true, and this will also print false because the negation of true is false. So let's test that out. As you guys can see, it's false, true, and false, and that's how Boolean operators work and Boolean logic works. Then we'll also have relational operators, but we'll get to that later when we're actually going through decision making. Okay, so it's time we move ahead. Okay, so now let's see how pointers actually work in Go. Now, pointers in Go are easy and fun to learn. Some programming tasks are performed more easily with pointers, and other tasks, such as call by reference, cannot be performed without using pointers. So it becomes necessary to learn pointers to become a perfect Go programmer. So as you guys know, every variable is a memory location, and every memory location has its own address, which is defined. And this can be accessed by using the ampersand sign, and this denotes an address. So as you guys can see in the piece of code, we have a variable called x with the value 5. Now printing x will output 5, while printing the pointer to x, which is ampersand x, will print the memory location. So let's try that out in our programs. So let's delete all this. Now suppose we have a variable x, which is equal to 10, and we want to print the value of x, and we also want to see pointer to x, which is basically ampersand x. Okay, so let's see what that outputs. Okay, as you guys can see, this is the value of x, and this is the address where x is stored. Now you guys might be asking, where exactly would I use pointers in a program? So let me just give you a basic example. Now suppose you wanted to change the value of x by passing it into a function. So what you do is you create a function called change value, and you pass in x. Now let's create that function here first. So change value, and you pass in x as an argument, and you say x equals 7, right? So now we want to print x. So fmt.println x, and what we are expecting is that 10 will be passed into this function, it gets changed to 7, and 7 will be printed here. But that's not exactly what's going to happen. So let's see. So as you guys see, x is still 10. So why exactly is that? Well, because the x out here doesn't have a scope out here. So it doesn't really mean that we're changing the same x. But if we were to actually send the pointer to x, then this would have a different effect. Now x is 7, as you guys can see, because we changed the value at the memory location. So this is where pointers are extremely helpful. You want to change something at the memory location, you basically use the pointer. Okay, so that was all about pointers. Now let's move ahead. So Golang also gives us an option to custom print using the printf function, which is in the format library. Now I've demonstrated a few of the implementations of the function as below. So as you guys can see, we have the format.printf function in this piece of code out here. So firstly, the %f lets us format print a float number. %t lets us show the type of anything. Then small t with percentage shows us a boolean. %d is used for showing integers. Now, instead of me showing you through the PowerPoint presentation, let's go and actually code a little. Okay, let's remove all this first. Before we get into format printing, let me show you all a bit of strings. Now, we had discussed that we have this data type called string, and it's basically a character literal. Now, to define a string, you could go var name and type, which is string, and then you define the value, which is aria Paul. Now, if you wanted the length of this name, you could just go format dot print line length of name. Let's go and run that once and see. Okay, so my name is 10 characters long, including the space. So we got that right. Now, we can also join sentences with the plus sign. So let me just show that once. So format print line, you can go name plus probably is a chill dude. So you could do something like that. And this will now print out that I'm a very chill dude. Yeah, so our Paul is a chill dude. Now that we have seen how strings and stuff work, let's go through the printf functions. So printf is basically formatted printing. So let's try out all the ones that I can think of from the top of my head. If you all want to go through all of them, I suppose you could go through the documentation. So format printf. So suppose we wanted to print out a float. So we'd go %f, and we also have to specify that we need a new line, and then we'll just print out any floating point number. For that, we also have to kind of define it too. So constant pi, which is a float 64, equals 3.1412345, whatever. Now that we have actually defined our float, we can print it out. Okay, now we've printed out the entire float. You could also specify the precision you want by saying something like this, that 0.3f. Now it'll show us for 3 precision. Let's try that out. Yeah, as you guys can see, it's just 3.141 now. Now, if it was a 5 out here instead of a 2, it would have probably rounded it off to the next value. Now, we can also print the type as I had discussed. So we can go format printf, and %t should give us a type. So %T will give us a type, new line, and let's check out the type of name. So it should print string. Let's comment these out for once. Yep, so it showed us the type that name is, and that is a string. Now we can also print booleans with the printf function, as I had shown in that piece of code, and that is by saying %small t. So for that, we need a boolean first, so let's go and do that. Win true. Now we can just print a win, and it'll print true. Okay, so that's that. Now %d is used for integers, so let's see that. First, let's define an integer, and let's print out x. So that's going to be d, and this is going to be x. Okay, so that worked. Now we can also print binaries using the printf function. So for binary, we go %b, new line. Suppose we wanted the binary of the number 25. So this would print the binary of 25. So 110001 is the binary of 25, and you guys can check it in your binary calculators, and I'm sure it's right. Okay, we can also print the characters associated with a key code, if I remember correctly. So that is given by printf and %C. So let's try 33. What exactly is 33? Let's check that out. Okay, I forgot my comma out here. Okay, so that's an exclamation mark. So we come to know that. So 34 is probably a question mark. Let's check that out. Okay, it's that thing. So we can also print the characters that are related to the ASCII codes. Then we can also print hex codes. So let's try that out too. So you can print hex codes with the %X sign. So this will print out the hex code for whatever value you input into it. So suppose we want the hex code for 15. As we all know, as hex in F is 15. Now we can also print scientific notations. So let's see that. So fmt.printf, the scientific notation is given by %E. You want a new line, and let's print pi. As you guys can see, that prints it out in a scientific notation. Okay, so that was all about formatted printing. And this taught us how we can print different objects and different data types with different escape characters. It's time we move on to loops now. So if you're new to programming, a loop is basically an iterating mechanism in computer science, and it's used mostly when you need to perform a repetitive pattern in programming. Now, in most programming languages, there are three types of loops, namely for, while, and do while. But Golang has only one type of loop, and that is a for loop. The syntax of Go, though, allows while loops to be implemented with the syntax of a for loop. Now, before we get to coding loops, let's take a look at the general structure that is followed in Go for looping. So the code that you guys see on the slide, for loop with three different parts. So firstly is the declaration of the iterator I, which has been set to 1. Then we have the limit of the iterator, which has been set to less than 5. And then we have to set the incrementation of the iterator, which has been set by I++, which is basically a shorthand for I equals to I plus 1. Okay, so now that we know the structure of a loop, let's try and practically implement them in our very own Go program. So let's head over to our text editor. Now let's remove all of this first. Okay, so first of all, we will try to print the first 10 numbers using a normal loop. So let's say for I equals 1 and I less than equals 10 because we want to go up till 10, and I plus plus. Okay, these have to be semicolons. Please remember that. Then we just open up our loop bracket. Now what we want to do is print out I. So we can go format.println and we just want to print I. Okay, so that should print all the numbers from 1 through 10, and that's exactly what happens. Now we can also define a loop like this, which is basically making it into a while loop. So we can go I equals 1, and we could just say for I less than equals 10, then format.println I, and we have to also increment I. So this will also do the same thing, but in a while loop sort of fashion, because this is kind of an exit control loop now. And as you guys can see, we implemented the same logic in two different ways. Now we can also have a loop inside a loop, just like every other programming language, and we can use that to build patterns and whatnot. So let's try it out once. So for I equals 1, I less than 5, I plus plus. Now inside this, we're going to have another loop for j equals 1, j less than I, and j plus plus. All we want to do is go format, print, and we want to print a new line here. Okay, I forgot the quotes. And if you use printf, you get a really cool pattern, something like this. So that's how you use nested for loops also, and nested loops in general in Golang. So now that we're done with implementing loops in our very own Go program, it's time we moved on to decision making. Now, decision making is used in computer programming whenever we need to make a decision based on logical steps. So let's take a look at this code for an example. So we have a variable called age, and it's set to 18. Now, we have to decide whether this person of age 18 can vote or not. So if age is greater than 18, You gotta print you can vote, else you print you can't vote. So this is how proper decision making control flow actually works. So first, when you meet the if statement, the computer decides whether it's true or false. So if it is true, the conditional statement is executed and the program moves on. And if it's false, the control flow of the program just moves on after the conditional statement. Okay, so let's implement decision making in our very own Go program now. So there are two ways you can actually implement decision making in Go programming. So one is through the if and else if, and the second one is through switch statements. So let's try our very own decision making program in Go. So first we define an age, and now we're going to decide if this person can vote. So if age is greater than 18, then this guy can vote. So format print line, yes, you can vote. Else, be very careful of the syntax. So I'll give you a syntax error. Else has to be on the line that we ended here. Now else, we have to say format print line that no, you can't vote. Let's save that. Let's run that. So as you guys can see, since 18 is definitely not greater than 18, so the program prints out, no, you can't vote. Now, decision making, as I said, can also be done with switch statements. So let's say something like this. So we want to switch the age, and we'll set different cases. So suppose our guy is 16 years old. So we say format print line, prepare for college. If he's 18 years old, probably he's trying to get a girlfriend. So we could say something like, don't run after girls. Or you say case 20, and we could be like, get yourself a job. Or the default case, in which case we're going to print, are you even alive? So at this moment, you're going to see don't run after girls, but this is when you have specific operations for specific cases. Like for case 16, we'll have a specific operation. Case 18, we'll have a specific operation. And then we also have a default operation. So let's run this and see. So as it says, don't run after girls. If we change this to 16, we'll see whatever's in case 16. Let's prepare for college. And if we make this something like 78, then the default case will run, and it'll just say, are you even alive? So that's how switch statements work. Okay, so that was all about decision making. So now it's time we move to arrays. Now in Go programming language, we are given a data structure called an array, which can store same types of data in one variable basically. So suppose we have student count, and it's going to store 10 different student counts, and it's of int type. So that's how you define an array. So basically an array is used to store a collection of data, which is often more useful to think of an array as a collection of variables of the same type. Now let's go and implement them in our Go program. You'll have a better understanding through that. So first of all, let's delete everything that we had created. Now let's define our first array. So let's call it even numbers, even num, and we're gonna store the first 5 even numbers, suppose, so 5, and they're gonna be of int type. Now we can also initialize all these even numbers like this. So at index 0, we're gonna have 0, and let's copy this out now. Okay, so let's say, so 1, 2, 3, and 4. 2, it's gonna be 4, it's gonna be 6, and it's gonna be 8. Now that's how you initialize the members of an array. Now suppose you want to print third element. So you'd go 0, 1, 2. So that is second one is the third element. So you'll say even num and the second one. So that should print out 4 for us. So let's see if we are right. And we are exactly right. So it prints out 4, and that's how arrays work. Now you can also initialize arrays in multiple ways. So first of all, let's delete this. rather commented out. Now you could have gone something like even num, and then using the shorthand notation, you say you're gonna have 5 of them. You say they're all gonna be ints, and then you just initialize them in curly braces. So 0, 2, 4, 6, 8. Now that would also give us the same thing. Let's uncomment this, and it should print 4 again. So that's how you can also initialize an array. Now we can also iterate through the array through all the members using a for loop. Now that's very important. So we don't really need the index for the for loop, so we can do something like this. Now there's also the range value. So value equals range of even num, and we are going to print the value. T.println value. So this will iterate through all the members of the array. So as you can see, it's 0, 2, 4, 6, 8. Now this underscore means that we are not actually using the iterator, and the value is still the range of even numbers. Now if you would also like the iterator to be there, you could just simply put this as I and then say I out here, and that would also print out the values along with their indexes. So 0 is at 0, 2 is at 1, 4 is at 2, 6 is at 3, and 8 is at 4. Now, there's also something called slicing. Now, every array can be sliced in every programming language that is there, and Golang is no different. So how exactly do we slice arrays? So what exactly is slicing? Well, slicing means that you are taking some subpart of the array. So suppose we want to slice this array from the third element, so we would only get these. So that would be our slice. Now let's see how we can actually slice arrays. So mostly sliced arrays are just like arrays, but you just leave out the slice of the array. So suppose we go num slice, and you can go something like int, and you can just initialize it like 5, 4, 3, 2, 1. Now we're going to try and slice this array. So our sliced array will be stored in a different array. So we are going to call it sliced, and we're going to slice our num slice array, and we're going to slice it from the third value to the fifth value. So that is from 3 up till 5, not including 5. So you go 3, colon 5. Now let's just print out sliced, fmt.println sliced. Okay, I made a mistake here. So as you guys can see, it gave us 2 and 1, which is from the third to the fifth. That is third and fourth, basically. Now we can also slice an array backwards. So that can be done like this, which is you do not give the first value and it'll be just assumed to be 0. So it can give you everything, or you can do something like this, 0 up till whatever there is. So this will also give us the same output, 5, 4, 3, 2, 1. So you can also create an empty slice and define the data type. So we do it something like this. We go slice2, and we use the make keyword, and open close brackets, and 5, 10. And you can copy the contents of one slice to another slice. So you could be like copy slice2 into num slice. Now let's print out stuff. So println, and we print out slice2. Let's see what happens. Okay, so this was like this. And as you guys can see, that was it. Now we can also come and num slice out here and see that has also been copied into, and it's the same, it's been copied into, and it's the same thing. Amazing. We can also append values to a slice, and that is done with the append function. So we go slice3 equals, so we want to append something like num slice, and we're going to put 3 with 0 and -1. Okay, so as you guys can see, we have successfully appended 3, 0, and -1 to our already sliced array. Okay guys, so that was all about slicing and arrays. The next thing that we're going to study is maps. So maps is basically like a dictionary. It provides us a key value pair kind of data structure, and it's used for hash maps. So if you have a value to a word, something like Theodore Roosevelt out here, he's matched to the value of his age. So we can create a map for such stuff. Now this is how you exactly declare a map. You go for the name of the map and then use the make keyword and then the map keyword and then the type of the value and then the type of the key. So int is the string is the key and the int is the value. So it's better that we go and just implement it because it gives us a better understanding. Okay, so let's create our map first. So let's call it a student age, and it's gonna have the name of the student as the key and his age as the value. So we go make map. So inside is gonna be a string and it's gonna be an int. So something like this. So student age area equals 23, or student age something like Saurabh equals 27. That's how you initialize your maps. Then you could also put a lot of stuff. Let me just copy this and make a definite map. Now let's call this person Prerna. Let's call this person Akriti. Let's call this person Sahiti. And let's call this person Kirti. So Prerna is 21. Akriti is 19. Sahiti is 42. And Kirti is 22. So this is basically a map of all the student names and their ages. Now, if we were to go and print something like this, fmt.println, so let's say student age, let's see what happens when we just print student age, actually. It prints out the entire map for us, and we can also print a particular value by giving it the key. So suppose we want Kirti's age. So Kirti is 22 years old, and that's what it should output. Okay, so as you guys can see, it's output 0 because I've put a small k out here. So it has to be exactly case specific. So if I were to make it capital now, output 22. Okay, so that's how maps work. Now we can also have maps inside of maps. Now, before we move ahead, let me show that you can also find out the length of a map. So we could go something like, let's print out length. So length of student age. So this should give us 1, 2, 3, 4, 5, 6. Let's see. So that was 6. That's amazing. Now we can also have maps inside of maps. And this is mostly used when you have a mapping to a mapping. You'll get to that when you actually code for the industry or something like that. But let me show you an example in a simplistic way. So let's say this is what we do. So for a map inside a map, suppose we have a map for superhero. And that is basically a map of a string, which is again mapped to a string. And it's also string. So we would initialize something like this, so Superman, and you're going to map Superman to a string again, and you're going to say real name is Clark Kent, and he lives in a city called Metropolis. Then you could also specify another map, give it a comma, and just, so we could go something like Batman will be mapped to a string, and the value will also be a string. Now a real name will be Bruce Wayne, and city will be Gotham. Okay, so that was that. Let's close out our map. And we can output the data where the key matches Superman. So let's see. So we can do something like if temp, comma, hero equals superhero. Okay, now that we've actually created our maps inside a map for superheroes, we can actually print out the data. So how exactly do we do that? We do that by going if temp and hero equals a superhero, where superhero is Superman. So we can say hero. Now you just have to print. So we go temp, real name, and city. Okay, so that's how we actually make maps inside of a map. Now let's go and run it. Unexpected new line. Okay, expecting a comma. Okay, we need a comma out here and a comma out here. 12. I forgot my commas. String map but not used. Okay, that should clear out all the errors. Now it's compiled, and we should see our output, which is Clark Kent and Metropolis. So, despite all the errors, we have solved our program. We should put commas after every event. It's not an event, rather, it's a part of the map. So, after every part of the map, we should put a comma. That's what we learned, and we have forgotten equal to out here. Now, that was all about maps. Okay, so let's move forward. So next up we have functions. Now Golang also allows us to make our custom functions, which will be used for our custom uses. So like in this piece of code you see out here, we have a function called add, and it takes in two arguments, which are a, b, and they're of type int, and they'll also return an int. So this is the return type that we have specified out here, and then we are returning a plus b. So adding custom functions to your program will make it in a more modular fashion and make your code much more reusable. So let's see how we can use functions in a Go program. So let's delete all this first. Now let's create two variables. So x comma y equals 5 comma 6. So suppose we want to add these. So let's send x and y. Now we can just directly print it out here. Now that we've actually called a function, we need to go and create it. So func add. Now this is where you set the argument. So we are sending two numbers. So you could either go num1 comma num2, and they're both ints. Then we also have to specify the return type. So that is an integer too. Now we're returning num1 plus num2, and that's about it. So it should output 11 now. Okay, we have an undefined num2. Okay, so we forgot to say num2 here. My bad. And now this should say 11. Yep, just as we had expected. Now you could do this for other stuff, like you could make this subtraction, you can make this into a division function, or any other function that you would like to create. Okay, so that was how we could create a custom function. Now we can also do something called recursion with functions. So recursion is when you call a function from inside of itself. So let me show you the slide for that one. So yeah, so suppose you were calling factorial from inside of factorial. That means you're setting up a chain of calls to the function until this value is actually satisfied. Now let's see what that actually means. So suppose we want to print the factorial of a number. So we have a num, and let's say it is 5. And we want to print the factorial of 5. So we say factorial and 5. Right? Now, what we need to do is create the factorial function. So func factorial takes in one number, num, and it's an int, and also will return an int. So int, and there you go. So first of all, we need to say that if num equals to 0, then we return 1. Else, what we do is we just say, else we're going to return num into factorial of number minus 1. So this will basically call here first. So first 5 will come here, then 5 minus 1, 4 will be called, then 4 minus 1, 3 will be called, and we'll get the factorial. So let's see if that works out for us. So num is not declared, but not used. Okay, yeah, we had to pass in num instead of 5. So this should output 120 for us because that is the factorial of 5, and voila, we have 120. So that's how you use recursion in Golang. It's a very optimizable way of actually implementing a function where you're calling itself, and you should always use recursion when possible. Okay, now moving on, we have some Go specific languages called control structures. Now these are basically three functions, that is defer, recover, and panic. Now let me just theoretically tell you all, because this is a very Go specific thing. So a defer statement defers the execution of a function until the surrounding function returns. So then multiple defers are pushed into a stack and executes in the last in first out order. Now, defer is generally used to clean up resources like files, database, and connections. So suppose you have opened a file using Go, and if you'll open a file, you'll always have to close it, but some people might just forget. So you could put a defer saying that you'll close the file after all these functions are done, and defer will do that automatically for you. Then we have the recover function. Now, recover is another built-in function in Go, and it helps regain the normal flow of execution after a panic situation. Generally, it is used with the defer statement to recover panic in a Go routine. Thirdly, we have the panic function, which is similar to throwing an exception in any other language like Java or C. And generally, when a panic is called, then the normal execution flow is stopped immediately, and the deferred function are executed normally. It is a built-in function in Golang. Now let's see how these are actually used. So suppose we have two functions basically. So first run and second run. Now, since we're calling first run first, that's what should run first, right? So let's create these two. Func first run, and it'll just print out I executed first, and we'll also have a second run. Now let's see, I executed second and second run. Okay, so if we run this, we should see first I executed first and then I executed second. Yeah, so that's how it's worked. Now what if we put a defer out here? So we say defer, and this would make second run first because defer runs after all the surrounding functions have already finished. So we'll see how this actually works. So as you guys can see, I executed second, which is second run runs first, and then I executed first runs after this one. So that is how defer works. Okay, now that we have seen how defer works, let's see how we can use recover and panic to actually handle our errors. So suppose we want to divide two numbers safely. So let's say we're trying to print two numbers, print line, and we go something like div, say 3 comma 0. So whenever we're dividing by 0, it should throw an error basically. And we can also do fmt.println div 3 comma 5. Right. So now let's make the div function. Func div, first of all, is going to return an int. And wait, it's going to take in two numbers, num1 and num2. And both of them are going to be ints. And it's going to return an int. Now we want to defer a function first so that it runs last, and we're gonna recover from this. So this is how you use recover with defer. So basically after everything is done, you want to recover from the situation that you probably created for. So you use recover with defers because you want to recover from the situation you've created from yourself, and you want this program, this function, to run after all the errors have been created. Now you want to say solution equals to num1 by num2, and you're going to return the solution, right? Now you have a sum called panic, and this is a demonstration of panic, and you defer a function where you're again going to recover. Let's print our recover statement here. And in the end, we can go and say panic. Okay, so we also have to call panic here, and that's about it. Let's save this and run. So this should throw an error, basically. Yep, so you see, we threw the error was like nil, and then panic. So that's how you use defer with recover and panic. Now, you can also pass an unlimited number of arguments to a function. I forgot to cover that, so let's go through that quickly. And suppose you have an array. Suppose a list of numbers. So let's say list equals to its list of 5 numbers. They're all ints, and it's basically 10, 20, 30, 40, and 50. Right. Now we don't really know the number of arguments that are going to be passed. Or let's not do it like this. That's actually a list. We can easily pass a list. So suppose we're going to add them all up. So println add them up is a function, and we're sending 10, 20, 30, 40, 50. Now we want to add all these up. So make a function called func add them up, and you say args dot 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 and int, because that's the type. And you also want to return an int, and then you want to cycle through all the arguments. So value equals range args, and you just want to add them up. So value, okay, or rather we need a sum now. Sum equals 0, and then we say sum plus equals value, which is basically sum equals to sum plus value. Then we also need to return the sum, and that should do it for us. So this will just add up 10, 20, 30, 40. Okay, non-declaration statement outside function body. Unexpected range and expecting expression. I think I made a few mistakes. Let's go through them. So first of all, this shouldn't be a semicolon, it's a comma. See if that fixes it. Okay, non-declaration statement outside function body. So then, okay, we put a stupid bracket there. Undefined value. Okay, so this has to be like this. Okay, so that seems to have compiled our program, and now it's going to give us the addition, which is basically 150. Okay, guys, so that was how you pass unlimited number of arguments into a function. And I think that ties up functions and all the special types of functions that we had. So let's move on with our tutorial today. Okay, so now that we've covered the Go specific function, let's move on to structures. So Go allows you to define variables that can hold several data items of the same kind. So this is called a structure. Now a structure is another user-defined data type available in Go programming, which allows you to combine data items of different kinds. Now structures are used to represent a record. So suppose you want to keep track of the books in a library, you might want to track the following attributes of each book, like the title, the author, the subject of the book ID, and in such a scenario, structures are highly useful. So to define a structure, you must use the type and struct statements, and the struct statement defines a new data type with multiple members for your program. The type statement binds a name with the type, which is the struct in our case. So in this example, we have created a structure and named it rectangle. It has the left position, the top Y position, the height, the width, and then we are passing in a rectangle type into an area function, and we are going to actually calculate the area. So let's see how this works in a normal Go program. Okay, so first let's delete all these things. So first of all, let's define our structure first. So let's see, type rectangle, and it's going to be struct. Now we're going to keep this simple, so we're just going to give this two things. One's the height, which is going to be float 64, and one's the width, which is going to be float 64 again. Now we can calculate the area of this thing later on. Now that we've created a structure, let's create a rectangle type data. So there are a few ways to do this. So first of all, we could go something like rect1 equals rectangle, and then we could do something like this. So we could say height is, I don't know, 10 and width is 5, right? So that does it for us. But we could, if we knew what order our characteristics came in, like that's height and width, we could just simply go 10, 5. So that'll set the height to 10 and the width to 5. Okay, now we could also access these characteristics with the dot operator. So we could go something like fmt.println. Suppose we want to know the height of rectangle 1. So we go rect1 dot height, right? So that should print it out for us. Oh boy, undefined rect1. That should solve it. Yep, so that printed out 10. Okay, so that's how you actually refer to your characteristics of your new data type, that is rectangle. We could also print out the width if we want. We would do it something like this. And now it's going to print out both the height and the width for us. So that's 10 and 5. Nice. Now we can define methods for a rectangle by adding the receiver rectangle between the functions and the function name. So we can call it with the dot operator. So something like we need the area. So let's say we have a func area. Now we can also create custom functions for our structure. So suppose something like this. So we wanted to print the area. So we want an area function for our rectangle. So we go rect1 dot area. So how exactly do we create this area function? Well, you go and type func, and then you say you're going to pass in rect, and it's going to be a type of rectangle, and it's going to have the function area, and it's going to return float 64. Never forget that, and it's going to be rect dot height direct dot width, right? So that's how you do it. Now that's it. We have the area. So area is 50. So just to make you guys realize this, let's comment these two out and make this something more proper. Area of rectangle is the space. So area of rectangle is 50. Area. Yep, so area of rectangle is 50 as we just see. So that was all about structures and how we can also create our custom functions for them. Okay, so now that we're done with structures, it's logical that we move on to interfaces. So what exactly is an interface? Well, in Go programming, it's provided with another data type called interfaces, which represents a set of methods and signatures. Now, the struct data type implements these interfaces to have method definitions for the method signature of the interface. So basically, you're going to have an interface like type shape, and it has an interface of area. Now, you basically have different area formulas for different shapes. Like the area of a rectangle is height into width, while the area of a circle is basically pi r squared. So, okay, so now that we know what interfaces are, let's go and try them in our very own Go program. So let's begin. So we go package main, right? And then we're going to import a few packages like format. Actually, we're going to need math too. So format and math, right? Then we go and start off with our function main. So func main. Let's leave this blank for now. Now let's create our interface first. So type shape. So it's going to be an interface. Now it's going to give us the area. So we have an interface for area, and it's going to be float 64, right? Now we are going to have a structure for a rectangle, and it's going to be a struct, and it's going to have height, which is a float 64, and the width, which is also a float 64. Now we're also going to have a circle structure. So it's going to be a struct, and it's just going to have a radius, which is going to be float 64. Right, guys, so now we need the area functions. So we're going to pass in a rectangle, and it's going to be an area type. It's going to return a float 64, and it's going to be returning r1.height into r1.width. Now we also need a function to calculate the area of a circle. So we're going to pass in a circle C1, and it's going to area this thing, and it's going to return a float 64. So this is going to return math.py into math.pow, and we're going to pass in C1.radius, comma 2. Now we're going to need the func of get area, function get area. We're going to pass in a shape, which is going to be of type shape, right? Type shape, yep. And it's also going to return a float 64. Here we're going to call the shape dot area, shape dot area. Now we need to create our instances. So let's say rect equals to rectangle, and it's going to have 50 and 60 as its dimensions. We're also going to have a circle called circ, and it's going to have a circle type, and it's going to be 7 radius. Now all we need to do is get the areas. So format print line, area of rectangle is rec dot get area, I guess. No, not rec dot get. We just call get area. I'm gonna pass in rect, and we also need the area of circle is comma get area of circ. Okay, so let's see if we've done that properly. As you guys can see, we have the area of the rectangle, which is 3000, which is basically 50 into 60. And we also got the area of the circle, which is 153.93. So that's how you implement interfaces in a Golang program. Okay, so now that we're done with interfaces, it's time we move on to file input output. So Golang lets us handle files and system processes with the OS package that is already pre-built into the Golang libraries. Okay, so instead of understanding code that is written on a PowerPoint presentation, it's much better that we go and execute code ourselves because that's the best way to learn coding. Okay, so let's get on with file handling. So this is how you would handle a file. So first we will need to import fmt, and we'll also need to import OS. So since we're importing multiple libraries, let's do it like this. Now let's create the main function. Now how do we create a file? So we give the name file. It might have an error. So os.create. Let's create something called sample.txt. Now you want to output if any error had happened. Now that you do with nil, which is basically none in Python, as you might have already known. We also need the log library for logging out our errors. So we'll go log.fatal and we'll show the error. Then we can also write to this file. So we can go file.write string. It's going to be capital. Yeah, write string. And let's say, hi, my name is Arya, and this file was created using Go. Then you have to close the file after you're done. So file.close. So let's run that. Importer not used fmt. Okay, let's comment that out for now because I want to show you something. Okay, this was supposed to be capital. Okay, so that's run our file. So this should have created a sample text. So as you guys can see, hi, my name is Arya, and this file was created using Go. Now you can also display this file as a stream. So let's try and open this file. So let's create a stream first. You can also have an error. And we are going to need io-util for this. So let's import that first. io/io-util. Then you go io-util .read file, and we want to read sample.txt. Right. Now, if there was any error, we want to always display that. So let's get that ahead. Now we need to convert this to a string. So let's call it s1, and it's gonna have string, and we're gonna convert the stream into a string. Now all we have to do is fmt dot println string s1. Right, now we need to also import fmt. Let's not forget that. And that is going to read out our file for us on the command line. So that's how you can actually import files, read them out, write to them, and that's all. Okay, so this has almost brought us to the end of our tutorial, but before we end, let me just show you guys how you could create a web server. So Golang gives you the opportunity or the ability to create a web server just in seconds because it has an HTTP library, and that allows us to do all sorts of things. So I'm going to be creating a very simplistic web server. So let's get started. Now let's delete everything first. So let's start from scratch, package main. And then let's say we need to import, first of all, quite a lot of stuff. fmt, then http slash, oh wait, it starts net/http, right? So let's get ahead and create our server. So func main. Let's leave the func main. So first we need to have a handler. So every page has a handler. So let's go http.handler. It's handle func if I'm not wrong. So handle func is, so suppose when you're going to the home page, which is /nothing. So we'll be passing in a handler. Now let's also create another page. So http/handle func/hello. will be handled by handler 2, right? Now we also have to tell which port to listen on, so http dot listen and serve. So we want to post on 8080 and it's going to be nil. Right, now let's create these handlers. So func handler. Now the handler is taking a writing response and it'll read also. So we set it up something like this. So http dot response writer and a request. Now what we want to do is when this handler is called, we want to write to the screen. So what are we going to write? We're going to go fmt.println welcome to my homepage. Now we also need a handler 2 in the same way. So this is going to be called handler 2 and when we're on whatever, hello. So let's print hello world. So this is going to be hello world. So this should set up our HTTP server. And let's see if it goes and compiles. Okay, it's response writer. Sorry. Okay, so now our server is up and running. So if we were to go to something like this, localhost 8080. Oh, I forgot fprint. So we have to use the fprint function here instead of printing. That's why it's not printing here. Fprintf, and this will also be fprintf. So it's going to show it out here, but we want to show it on the screen, right? And we have to also pass in w, which is the response. Yeah, that's about it. And we want to also give a new line. Let's not forget that. Okay, so our server is up and running again. So let's head over again. As you guys can see, this prints it out. Welcome to my homepage. And if we were to go to /hello, it would say, well, that's unexpected. It should say hello world. And wait, it should go to, okay, /H. Okay, that's my mistake. Yeah, so as you guys can see, if you go to HELLO, so it'll show hello world. So that was a different handler that should have been handled, but this was a very simplistic web server. Okay guys, so we went through a lot today in this Golang tutorial. We went through loops, we went through maps, we went through array structure, interfaces, and even created a web server. So if you guys did enjoy this Golang tutorial, don't forget to give it a thumbs up and subscribe to our channel. We'll be also releasing a lot more Golang tutorials. Please look forward to them. That's it from me. Until next time, goodbye.
I hope you have enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries, and we will reply them at the earliest. Do look out for more videos in our playlist and subscribe to Edureka channel to learn more. Happy learning!